Welcome to the exam special on chemistry. I'm Arjun Bhagat and today we're going to tackle the topic chemical kinetics. So tell me, are you all set for your exams? Not quite, but I'm certain that by the end of this episode you'll get a good grasp on today's topic. Let's begin our analysis by understanding what to expect in the exams in our trend spotting segment.
This unit on chemical kinetics carries a total of 5 marks out of a 70 marks chemistry paper. 5 out of 70 makes 7% of the total marks. That is a good lot, so pay close attention. We can expect very short answer type questions worth 1 mark from this chapter. You could also be asked short answer type questions worth 2 to 3 marks each.
Don't think that it's just 5 marks, but take it as 5 more marks. It's highly important to take chapters like this very seriously, as most of the time students lose out on marks as they take it for granted. So let's do a short recap.
In this chapter, we have learnt rate of reaction, rate constant, average and instantaneous rate of reaction, order and molecularity, integrated rate law for zero and first order reaction, half-life period, and temperature dependence of a rate of a reaction.
Now I hope you're already thorough with these topics. Let us have a look at the knowledge dip, where we tell you what the examiner is testing you on.
A close analysis of the previous year's question papers would reveal that mostly numerical ability questions are asked from the chapter Chemical Kinetics. Occasionally, questions testing knowledge ability are also asked.
Now that the chapter is fresh in your mind, let us start with the questions, because it is the answers that'll get you marks, irrespective of how well you know the topic. There's no point if you can't get the answers correctly. So take a look at a model question.
The following data were obtained during the first order thermal decomposition of dinitrogen pentoxide at constant volume. 2 moles of dinitrogen pentoxide gas on decomposition gives 2 moles of dinitrogen tetroxide gas plus a mole of oxygen gas. Calculate the rate constant. Let the pressure of dinitrogen pentoxide gas decrease by 2x atmosphere. As 2 moles of dinitrogen pentoxide decompose to give 2 moles of dinitrogen tetroxide gas and 1 mole of oxygen gas, the pressure of N2O4 gas increases by 2x atmosphere, and that of O2 gas increases by x atmosphere. The total pressure is equal to the pressure of N2O5 plus the pressure of N2O4 plus the pressure of O2. This comes out to be 0.5 plus x. Therefore, the value of x becomes equal to Pt minus 0.5. Substituting the value of x, the pressure of N2O5 comes out to be 1.5 minus 2 Pt. It is given that at t equals 100 seconds, the total pressure is equal to 0.512 atmosphere. The rate of reaction K is equal to 2.303 divided by time t into log Pi divided by Pa. On substituting the values of T, Pi and Pa, we get the answer as 4.98 multiplied by 10 raised to the power -4 per second. Remember to use the balanced chemical equation for solving such numericals.
Remember, questions are your best friends. They prod you to seek answers. Whether they are science questions or questions of life, finding answers to them is very important. We at Topper cannot help you much in finding the answers to life, but we can certainly help you solve science-related questions. And in science, practice is everything. So let us glance through some practice questions. In practice makes perfect.
State the role of activated complex in a reaction and also state its relation with activation energy. Take a look at the answer now. In a reaction, the reactants have to cross the energy barrier to change into products. When reactant molecules absorb energy, their bonds start breaking and new bonds of the products start forming. This highly unstable transition state between reactants and products is called activated complex. This activated complex is a transient or short-lived state, and the complex breaks to form products. This will fetch you 1 mark. Drawing the diagram as shown will give you a mark. The energy required to form the intermediate activated complex is called activation energy. And writing this much would get you the remaining 1 mark.
Great! Are you following it properly? Don't worry if you have any doubts, we'll clarify them as we go along. But now, without wasting any time, I'll straight away leave you with our next practice question.
A first-order reaction takes 69.3 minutes for 50% completion. Calculate the time required for 80% completion of this reaction. This question came in CBSE 2005 exams for 2 marks. From the question you can see that the value of half-life is given as 69.3 minutes. Substituting this value, we get the value of rate constant as 0.01 minute inverse. For calculating the time for 80% completion of the reaction, we use the integrated equation for first-order reaction. Substituting the values, we get the value of time as 161 minutes. Keep in mind that if the reaction is 80% complete, the concentration of reactant left at that time will be 20%.
We are at the halfway point in our practice session, so this would be a great time to revitalize ourselves before proceeding further. Up ahead, we have our remaining practice questions, our red-hot HOTS question, and at the end, we have a special topper treat, special tips to crack the exams. I'll see you after the break. In the meantime, try and solve this breaking question.
For the reaction A gives B, the rate of reaction becomes 27 times when the concentration of A is increased 3 times. What is the order of the reaction? This numerical worth 1 mark was asked in the 2006 CBSE exam. We rate the difficulty level as easy. We left you with our breaking question. Let's see what was that. For the reaction A gives B, the rate of reaction becomes 27 times when the concentration of A is increased 3 times. What is the order of the reaction? Let us consider the order of reaction to be N. Now we know that rate of reaction is equal to the rate constant multiplied by molar concentration of A raised to the power N. It is given that if the concentration of A is increased 3 times, the rate of reaction becomes 27 times. Therefore, 27 times rate is equal to rate constant multiplied by 3 into concentration of reactant raised to the power N. Dividing the two equations and solving, we get the value of order of the reaction N as 3.
Welcome back to our exam special on chemical kinetics. I'm Arjun. We have a model question which was based on first order reaction and practice questions from the topic order of reaction.
The decomposition of ammonia on a platinum surface where 2 molecules of ammonia gas decompose to give a molecule of nitrogen gas and 3 molecules of hydrogen gas is a zero-order reaction. Given that K is equal to 2.5 into 10 raised to the power minus 4 moles per liter per second. What are the rates of production of nitrogen and hydrogen gas? This question is for 3 marks and involves the recall of equation for zero-order reaction rates. Topper rates this question as average. The balanced chemical equation is 2 molecules of ammonia decompose to give 1 molecule of nitrogen gas and 3 molecules of hydrogen gas. Here, the rate constant is equal to 2.5 multiplied by 10 raised to the power minus 4 moles per liter per second. We know that in zero-order reactions, the rate is equal to rate constant multiplied by the concentration of reactant raised to the power 0. So, rate is equal to 2.5 multiplied by 10 raised to the power minus 4 multiplied by 1. This comes out to be 2.5 multiplied by 10 raised to the power minus 4 moles per liter per second. Using the values, we get the value of rate of formation of nitrogen as 2.5 multiplied by 10 raised to the power minus 4 moles per liter per second. Rate of formation of H2 is equal to thrice the rate of formation of N2. That is 7.5 multiplied by 10 raised to the power minus 4 moles per liter per second.
So how are you doing? Well, I'm really having fun in solving these problems with you, but you need to promise me that you'll practice even harder. And just to make sure that you do, let's see this 2-mark question which came in the 2008 CBSE exam paper.
Let's have a look at the question. What is meant by rate constant K of a reaction? If the concentration can be expressed in mole per liter and time in seconds, what would be the units for K? 1 for a zero-order reaction and 2 for a first-order reaction. The question here is average as per our difficulty meter. To answer this, you have to write that the rate constant K of a reaction is defined as the rate of a reaction when the concentration of each reactant is taken as unity. Defining this gives you 1 mark. To calculate the units, use the given equation where N refers to the order of the reaction. Substituting the values of N as 0 in the equation, the unit of K for a zero-order reaction is mole per liter per second. Similarly, substituting the values of N as 1 in the equation, the unit of rate constant for a first-order reaction is second inverse. That's all, and you get your second mark too.
That brings us to the end of this practice session. Today we revised the rate of reaction and rate constant. We learned to calculate the order of the reaction and the half-life period apart from the activated complex. Well, if that's gotten you all warmed up, then it's time to go to our hot segment. It's important to be worldly wise to do well in life. Now, keeping this in mind, the CBSE has launched the HOTS questions. Now, they want you to look beyond the books, to be aware of your surroundings. Who knows, they might ask you a question related to your daily life.
If a certain reaction is 50% complete in 20 minutes at 300 Kelvin and the same reaction is again 50% complete in 5 minutes at 350 Kelvin, calculate the activation energy if it is a first-order reaction. Given that gas constant is equal to 8.314 joules per Kelvin per mole. The value of log 4 is given as 0.602. While asking this question, examiner wants to check your numerical ability. This numerical is for 2 marks and is of average difficulty level. Here is the answer to it. At 300 degree Kelvin, T half is equal to 20 minutes and at 350 degree Kelvin, T half is equal to 5 minutes. So, at 300 degree Kelvin, rate constant K1 is equal to 0.693 divided by 20, and at 350 degree Kelvin, rate constant K2 is equal to 0.693 divided by 5. Now, recall that Arrhenius equation states that log K2 divided by K1 is equal to activation energy. EA divided by 2.303 into R multiplied by T2 minus T1 upon T1 T2. After substituting the values in the formula, we get the answer for activation energy as 24.2 kilojoules per moles. Take a look at the marks breakup with the steps. Also, note the final answer is in joules per moles. So convert it into kilojoules per mole. Remember that temperature should be in Kelvin.
This brings us to the end of our question-answer segments. Now I want to give you a suggestion on a personal note. Always have a strategy when you go in for exams. This will help you prepare for any surprise that may spring up, like the HOTS question. So stay inquisitive and study well. This will give you the confidence to tackle any paper with ease. But if you still have some doubts, you can always log on to our website www.topperlearning.com and have our experts solve them for you. Up ahead is a set of exam tips which will help you crack the exams with ease.
Use the given equation for calculating the unit of the rate constant for any order reaction. Be careful of the units while solving the numericals. In the numericals involving chemical equations, ensure that you are calculating the answer according to the balanced chemical equation. Practice all the graphs for zero and first order reactions.
Apart from all that we teach you here, I feel that one of the most important lessons students can take into the examination hall is a high level of confidence. As a wise saying goes, preparation tells you what to do, confidence allows you to do it. So stay positive, reach for the stars and make this your best exam ever. It's goodbye from me. See you next time.